This is a small-scale biogas power plant which is designed for production of mechanical power from chemical energy of biogas to generate electricity, which is the current problem in Ethiopia. This heat engine is built for many components which stand to perform specific tasks. Turbine enclosure is one of those components, and it is installed in front of turbine to surround the turbine so that the gas is allowed to pass only across the turbine. In addition to turbine, it covers stator vane where the gas is constrained to escape out of combustion chamber axially. This is turbine. Turbine is one of the two main components where mechanical power is extracted from hot gases. This turbine has 11 cm maximum diameter and 40 numbers of blades. It is designed to give 1.11 kW net power. The turbine is surrounded by a stator vane where the gas is adjusted to flow tangentially over the turbine. The stator vane is used to convert static pressure into dynamic pressure or enthalpy to velocity. Since changing velocity of gas across the turbine has a positive effect of increasing power output. In this project, stator vane is installed just overhead of turbine and behind combustion chamber. The combustion chamber is another component where mixing of fuel and air is takes place so that heat will be generated. The compressed air is flow over the combustion chamber and it diffuses into combustor while the fuel is injected into it through the fuel injector. The surrounding of combustor is made to be drilled circumferentially to allow diffusion of air into the combustion chamber. Generally, the combustion chamber is made from 6 separate components including the fuel injector. The drawn air by the compressor is needed to flow axially into diffuser, and this is done with the aid of the component called compressor enclosure. The compressor enclosure surrounds the compressor and prevents the air escaping out from the compressor radially before the air flow into the diffuser. The compressor is designed to keep 0.16 kg of air flow into the combustion chamber. The compressor has 10 cm maximum diameter and 40 numbers of blades. This is one of the main components called diffuser. Diffuser is made of aluminum and it's installed just above the head of compressor so that it converts the velocity raised by the compressor into pressure. This is additional component of the heat engine which is called hull. The hull is used to start the machine manually in order to allow the first gas drawn into the combustion chamber to give the first shaft power from turbine. The working mechanism for the hull makes the heat engine much simpler in such a way that the hull is surrounded by a rope and the wound rope is pulled or dragged tangentially so that the torque will be produced or generated. The required force to run the hull is not much bigger. It takes 54 Newton to generate the first reaction between the air and the fuel. 54 Newton force is nothing, but it's something like lifting 5.5 kg load.